Hi students, today we will discuss about superconductivity. This is the scissor you can find. Here this is the metallic part. Metal means it is a conductor. So when we will give the potential difference across the two ends of this metal, then the current will flow. The current will flow means it is the flow of the electrons. When electron flow across any conductor, then there will be a resistance. As per the Ohm's law, V equal to I into R. If there is a current, there is a resistance always there. But in 1911, the Dutch physicist K. Owens, while doing an experiment in his lab, he found that certain materials, they are giving the zero resistance value in a lower temperature conditions. So in 1911 he observed while reducing the temperature, then he observed in case of the normal metal the resistance is decreasing, and when you further reduce, then he observed that at 0 Kelvin there will be certain resistance value of the normal metal. But still there is few materials, they shows unique behavior at low temperature. He observed in case of mercury, when the temperature is decreased, then he observed this resistance value, it is decreasing like the normal metal, but at particular temperature this resistance value sharply falling down. The resistance value is sharply falling down at 4 Kelvin. So when he further reduced the temperature, he observed that the resistance value is totally 0. If we consider any materials where there will be no resistance, then the electrons will flow smoothly without any resistance, like this water flows in the river, and there will be no energy loss during the current flow. So this type of materials which shows the zero resistance at the low temperature is called the superconducting materials, and this superconductivity is a low temperature phenomenon. Another interesting part of this materials, if we will put this material in the magnetic field, then we can find it behaves differently. If we compare this at the normal metal, in the normal metal, if you put this metal inside the magnetic field, the magnetic flux or the magnetic lines of force will pass through this materials. But in case of superconductor, then if you put this in this magnetic field and magnetic lines of force, then when this magnetic lines of force is approaching towards the superconductor, it repel this superconductor. That means the lines of force expelled out from this superconductor, and the temperature at which any material achieves the superconducting properties, this temperature here, this 4 Kelvin, it is called this critical temperature, या TC. There are some other unique properties which is observed in case of those superconducting material. Let us discuss it. The Meissner effect, it is coming under superconductivity, and for the exam point of view, it is a very important questions. In the Meissner effect, the Meissner and Osenfeld at 1933, he observed that when a superconducting material is placed inside the magnetic field, then the magnetic lines of force, it is repelled away from this superconducting material. Here we can see this is a normal conductor and this is a superconductor. As we have explained before, in this normal conductor, it is T is greater than Tc, and for the superconductor T is less than Tc. As we have discussed earlier, Tc is the critical temperature. So when we are bringing this environmental temperature below critical temperature, then the normal material, it behaves like the superconducting materials. That means T is less than Tc, means this is the superconductor, and for this case our applied temperature is more than the critical temperature, therefore it is the normal conductor. In case of the normal conductor, this magnetic lines of force is when we are putting this material inside the magnetic field, the magnetic lines of force, it is passing through the materials. But in case of superconducting materials, the magnetic lines of force, it is repelled away when this lines of force approaching this superconducting materials. Let us discuss what is happening inside the materials when we are keeping it in this external magnetic field mathematically. So there is a relation B equal to mu naught whole bracket H plus M. This B is the magnetic flux density. It means how much magnetic lines of force passing perpendicular to this material. This is magnetic flux density. It is giving the idea about the magnetic lines of forces passing through this materials. Then this is mu 0. It is the permeability. Yeah, we can say it is this properties of this materials, how far it is suitable for this magnetic field. Suppose if we consider this iron, then it behaves differently in the magnetic field as compared to this plastic, because it is its original properties of the materials how it will behave this external magnetic field. This is the intrinsic properties of this materials. Then H is the applied magnetic field. When we are talking about, we are putting a material inside this magnetic field, that means we are giving an external magnetic field by putting the north and south magnet, north pole and south pole of the magnet. Then we are creating this magnetic field. So this is the applied magnetic field that we can control. If we want, we can increase also the magnetic field, that we will discuss later how the increasing magnetic field affect. But here this H is the applied magnetic field, that means how much magnetic field we are supplying to this materials. Then the magnetization, when we will keep any material inside the magnetic field, then this material become magnet after a few days. Like if we put this iron inside a magnetic field for a longer time, this magnetic properties is induced inside this conductor, inside this metal. So this is called this magnetization. Magnetization means the materials becoming magnet. There is some properties inside this atomic and molecular level, and it is being created if you put this material inside the magnetic field. This is called the magnetizations. So this is the relation B equal to mu naught whole into H plus M. But in case of superconducting materials, we are saying the magnetic lines of force, it is not entering inside the materials and it is going away when this magnetic lines of force approaching this material. What does it mean? That means this magnetic induction, a magnetic flux, becomes 0 for the superconductor. So if we put B equal to 0, then we will find mu naught whole into H plus M. So mu naught is the intrinsic properties of materials. It won't become 0. It might be very small number, but it won't be 0. So mu naught will not be 0. Then H plus M, it will be 0. Then H equal to minus M. So there is a factor which is called the susceptibility in case of the magnetostatics. The susceptibility is defined as M by H. That means magnetization divided by the applied magnetic field. So if we put H equal to minus M, we will get susceptibility equal to minus 1. So J equal to minus 1. Therefore, it indicates that this material is perfect diamagnetic material. That means superconductor has to obey this rule. If there is a superconductor, then it should obey this perfect diamagnetic properties. This whole is called the Meissner effect.